Here, we want to find the integral of 3 over square root of 2x minus x squared dx. Notice in here we have this square root, and then inside that square root we have this negative sign. And we want to use a trig substitution here, but in the trig substitution we have sine substitution and tangent substitution. So which one we're going to use? It depends on the sign in here. Since the sign is negative, therefore the substitution is going to be sine substitution. But notice here, it has to be in the form of square root of a square minus x square. So we need to rewrite that fraction. So we need to rewrite this square root. How are we going to do that? We're going to use this note here in orange. What we're going to do is we're going to complete the square. So I'm going to take what's under the square root, which is 2x minus x squared, and then I'm going to complete the square. So this, I think, going to be equal to x minus 1 squared, and then minus. So let's find that. So it's going to be minus, and then x squared, and then minus 2x plus 1. This is going to be equal to minus x squared plus 2x minus 1. Notice in here, this is what we have, and this is exactly in here. But we don't have this minus 1. Therefore, I'm going to add plus 1 in here. And that's going to be equal to 2x minus x squared if I arrange the terms. Now, the left side equal to the right side. So this integral can be written as 3 over square root of 1 minus x minus 1 squared dx. Now, it is in the form of the square root of a squared minus x squared. So we are ready to make the substitution. However, note in here, our x is not alone. Our x is x minus 1. Therefore, the substitution is going to be x minus 1 equal to a. A here is just equal to 1 multiplied by sine of theta. So we have x minus 1 equal to sine of theta. Now let's take the derivative of that. It's going to be dx equal to, and then the derivative of sine of theta, going to be cosine of theta d theta. Now let's take the integrand and rewrite it using the sine substitution. So the integrand here is 3 over square root of 1 minus x minus 1 squared. That's going to be equal to 3, and then over, and then the square root of 1, and then minus, and then x minus 1 is just sine of theta. So we're going to have sine square of theta, since that term is squared. Now notice this term in here, and notice this identity in here. We have cosine square plus sine square equal to 1. Therefore, if we solve for cosine square, it's going to be equal to 1 minus square of theta. So the dominator here is going to be equal to cosine square of theta. Now we can take the square root, so it's going to be 3 over cosine of theta. Now let's take the whole integral. So we have the integral of 3 over square root of 1 minus x minus 1 squared dx equal to 3 over cosine of theta. This is what we just found. And then notice that dx is going to be equal to cosine of theta d theta. Now notice that this cosine will go with this cosine, and then we have the integral equal to 3 d theta. Now what's the antiderivative of a 3? Just going to be equal to 3 theta plus a constant. Now after we simplify the integrand and then we simplify the integral, let's back substitute what is the function of theta. Let's write it in terms of x. We will use this one in here to solve for theta. So theta is going to be equal to arc sine of x minus 1. Therefore, this is going to be equal to 3, and then arc sine of x minus 1 plus c. And that should be the antiderivative of the integral.